All right, talking about section 5.1, it's got to do with area. And in particular, we're going to be talking about area under the curve. That's one of the key things. And I wanted to demonstrate the logic of it. And I think this little kind of presentation hits it nicely. I think it was a clear thing for me. That's why I'm choosing it. I think that let's go to the iPad. I want to clarify some things and show you what I mean by integration, finding area under the curve, etc., and what that's actually doing. We'll go into it more tomorrow as well, but I want to hit this kind of strongly to be clear on it. Let's start with this idea right here, get the concept across. Start right here with the idea, if we're starting off, this graph up at the top right corner is what I'm looking at. The velocity on the side, and time is on seconds. We've got feet per second up on the y-axis. And let's say we're starting off with, we're moving at 30 feet per second. And we do that continually for 4 seconds. Okay? Do that continually for 4 seconds. All right? Then, well, you recognize that if you take velocity and multiply times time, that equals the distance traveled. Right? So as a result, we would have been going 30 feet per second without writing increments right now, times the 4 seconds gives us that we would have traveled 120 feet. Feet per second and seconds cancel, you know, the seconds cancel, you end up with feet for the final answer. So the answer was we traveled 120 feet total. And that's a distance. The rate that was maintained is across the top, the graph of that, and the area under the curve is actually the amount of change that happened, which was how far did you travel? It's kind of a neat little moment. Well, we've got another situation here where there's a curve in this situation where, look at the top left problem here, the diagram I've got drawn, where you're starting out, we start out at 20 feet per second, and it increases up to 30, it goes up to 38, 44, 48, and finally 50. It's not an even rectangle, you know, it's not an even flat drawing. It's not a flat graph. So it's a little less obvious about what the area is underneath that curve and how far we travel. So one of the things that demonstrate this nicely is talked about, they do it in the text, but I like this presentation here, a little different than what they say, but it's what I'm saying, and catch it. The idea is that if you take the lower end of the interval, every 2 seconds, the rate is measured. So after 2 seconds, you're going 30 feet per second, at 4, 38, 6, 44 seconds, feet per second, and at 8, 48 feet per second, etc. So how far do we travel? Well, let's make a lower estimate, something we know will be below the actual value. And if we start at the bottom here, when we call that the left side estimate, you might call the low side estimate, draw a rectangle from there, go across at 20, we know we went further than that. But if we maintain that for 2 seconds, that's what would be an estimate. The next one was at 30. The next one's at 38. Then 44. And then 48. Okay? So it's a matter of totaling up, what is the area of those rectangles? So a lower estimate would be, these are all 2 seconds wide, so we've got 2 times 20 plus 2 times 30 plus 2 times 38 plus 2 times 44 plus 2 times 48. And if I factored out all the 2's that we had from that situation, we would have what, 20 plus 30 is 50, 88, 132. That it turns out to be 180, which gives us 360 feet. That's the low estimate. All right, let's do the same thing on the high end. So if we go up to the top right of the curve at each of the intervals, top right this time and draw a rectangle in that way, we've got this rectangle that's up there at 30. We've got 38, 44, 48, 50. And this time we've got this area going the whole shot, okay? The first time we had, I could draw the other direction, you know, we just had the bottom portion, which is the low estimate. Now, what is the total for the high estimate? Check this out. So this is the higher estimate. We know it's higher because it's above all the way. It touches and the area is above for sure. So it's a high estimate, so it's somewhere in between there. The high estimate is going to be 2 times 30 plus 2 times 38. You can see where this is going. 2 times 44 plus 2 times 48 plus 2 times 50 this time. So that equals, again, factor the 2's out, and we've got 68, 112, 160, 210. And we know that 2 times 210 is 420, don't we? 420, significant number. All right, now notice this. One thing you can point out here is that the amount of error that we had up here, notice that the amount that's added on each time is above the one to the left, a little bit above the one to the left. So it's going from 20 up to 50, and it's too wide. And the amount of error that we have here, this is too wide, and it's between 20 and 50, so this is 30. So the amount of error is 60. And notice the difference between 420 and 360 is 60. That error is 60 feet. Okay? So that's how much variation we have in our estimate. We know that it's off somewhere in that range. Well, let's check this out now. What if I made the interval shorter? What if I cut it in half? Okay, so we've got this curve that we had before, and that's the situation that we had. And this time, I'm going to cut the intervals in half. So I'll start with the left at 20, but go over to 1. And then at 1, I'm going to start where that is. Well, we don't know the exact number of this, but something we can gain from the information will be something we'll see in just a second. Okay, so check this out, halfway. And these rectangles now, this kind of makes a point kind of nicely, I think. That's 7, then we go to 8, then we go to 9, and the last one is there, we go to 10. We don't have the exact values of those, okay? And the one above is here, right? Et cetera, et cetera, et cetera. We don't know the exact numbers, but we do know that it's going from 20 to 50. And this time it's only 1 wide. So the distance is still 30. But the amount of error now has been cut down to 30. So it's getting smaller and smaller and smaller and smaller. All right. Yeah, if it's getting smaller and smaller and smaller, look what's happening. What if I go a half a second? Then it's going to be half times 30, 15. And then if I go a tenth, and then if I go 100th of a second, and if I go 1,000th of a second, it's getting smaller and smaller. And we've been talking about limits. And so as it gets smaller and smaller, the limit, so as this is getting tinier and tinier in between, you end up getting less and less error. And it turns out to be a smooth curve instead of these bumpy rectangles. So what we end up with is the area under the curve, the limit of these rectangles is going to give us the limit as the width goes to 0, okay, is going to give us a smooth curve, the area under that curve, right? So the idea is the limit, and I'm going to talk about this more tomorrow on Friday. And so as a result, let's do this. I know we talked today in class a little bit. Check this out, that if we have this situation here, I did this before earlier, that if we were to be on a vehicle or a bike or something, and we were able to start and increase and have our acceleration be consistent so that we, at 1 second, we were going 5 feet per second. At 2, we're 10. At 3, we're at 15. Okay? Then the area under this curve would be the total distance traveled. And this area is more legitimate. I can actually calculate this one, right? The area of that triangle is going to be equal to 1/2 base times height. And the 1/2 base times height gives us 1/2 times 45, which is 22.5. All right. And if you have the calculation capability of on your calculator doing this function, and what is this function? It's a line going from 0 to 3, and it goes from 0 to 15. So the y-intercept is 0, and what's the slope? Slope equals change in y over change in x, which is 15 over 3, which is 5. So this equation of this line is actually going to be y equals 5, and this is t, time, 5t. So we've got 5t here is the equation that we're doing. So if we do that function on our calculator, the integral of that function between 0 and 3, you'll verify, see, and check out that the answer is 22.5. That's a little exercise I'll leave for you, okay? So take a look at that. Go back over this if you need to, but that's the main theme about finding area under the curve. It's the sum of a bunch of rectangles, okay? It's getting smaller and smaller and smaller and smaller width. So, and we'll talk more about this on Friday, okay? So for right now, that's it. I'll talk to you downstream.